Okay, hello everybody. We're on page 6. We're working still with trig, and before we were evaluating trig expressions if we gave you an angle to evaluate a trig expression at. Now we're talking about if I give you a trig ratio and we want you to figure out what the possible angle would be. Now I should really specify for these, find the answers, all answers in that lie between, we'll just say that, the solutions that lie between 0 and 2 pi radians. So that's like just from 0 to 360 degrees. So in this first one, I have root 2 over 2. The ratio is positive. I remember from my trig triangle that when I have 1, 1, root 2, this is basically a 45, 45, 90. And that's also pi over 4. So I know the answer is definitely pi over 4 because that's quadrant 1. But it's also, because it's a sine ratio, it's also positive in quadrant 2. And that would be 3 pi over 4 radians. So I have two answers. I have pi over 4 and 3 pi over 4. For part 2, a 1/2 cosine ratio, it would have a reference angle of pi over 3. So you would have the adjacent being 1, the hypotenuse being 2, and this would be root 3. So you know that this is, this is 60 degrees or pi over 3. But you also have a positive ratio in quadrant 4. So that would be pi over 3 radians in quadrant 4 would be 5 pi over 3 radians. So those are my two solutions there. For tangent, to have a 1 over 3 ratio, I don't know if I have an angle for that. I don't think I have an angle that I cannot do without a calculator, so I'm going to just say we can't do that. But this one, we can definitely do a sine ratio of root 3 over 2. That would be pi over 3, and in quadrant 2 that would be 2 pi over 3. Now if you don't remember how to do this, this is definitely one of those things that in class we're going to go over and try to refresh your memory with. So I wouldn't really get too worried about this. We're just trying to get you proficient with this so that when we do hit it in the next month or so in calc, you understand what we're talking about and you can work through some of the problems. I don't want this to intimidate anybody out of taking the class, but it's something that if you do need help with, you should come in after school and we'll work through it. Okay? Number 12, solve the following equation. Well, with this, it's a quadratic. We've got a leading coefficient, and I've got to use the old x method to factor it. So what multiplies to give me 12 and adds to give me 12? Geez, I don't think there's anything out there that I can figure out for that. So, because 12 has 1 and 12 and 2 and 6 and 3 and 4, I think I'm kind of stuck here. So I think the only way I can really solve this is by using a graphing calculator, or by using the quadratic formula, or by doing completing a square. And I don't feel like doing completing the square because I have a very limited amount of room here. So I think I'm going to use the quadratic formula. My two roots are going to be so in this case, I'm going to now put in negative 12 plus or minus square root of 12 squared minus 4 times a is 4, the c is 3, all over 2 times 4, and then I'll have negative 12 plus or minus 144 minus 16 times 3 is 48. So that's going to end up being 96. So I have 12 plus or minus square root of 96 all over 8. Okay, I'm just going to break away and use a calculator to factor this out. So I'll be right back. Okay, I'm back. I just did a little work here on the scratch paper just to, figure out what perfect square I can take out of 96. And that's going to be, I can take out 16, which will come out of the radicals of 4. I'll have root 6 left behind. That's all over 8. And now I'm going to just factor a 4 out, and I'll have 4 negative 3 plus or minus root 6 all over 8, and then this will simplify to negative 3 plus or minus root 6 all over 2. So that will be my two answers. It will be negative 3 plus root 6 over 2 and negative 3 minus root 6 over 2, which for this type of problem you would have a calculator to help you figure out what the decimal equivalent would be. On the next one, in order to solve this, you would cross multiply. And then you would FOIL. You bring everything over to one side. And then you would try to factor it to figure out what your roots of this polynomial would be. So I'm going to need some more room. I'm going to move down here. And you would say, well, what multiplies to give you negative 6, because that's what 2 times negative 3 is, and adds to give you 5. So that would be negative 2, and I'm sorry, that would be negative 1 and 6. So now I know what my magic numbers are for factoring. I rewrite it as 2x squared minus x plus 6x minus 3, and now I'm on my way factoring. I have 2. I'm just going to factor out what's common to both, and that's 2x minus 1 there, and I'm going to factor out a 3 on this side, a positive 3, and I'll have 2x minus 1 here. And now I can find my factors, and my answers to this are x plus 3 equals 0, so x equals negative 3, and 2x plus 1 and minus 1 equals 0, so I have x equals 1/2. So those are my two zeros. On this next one, solving this problem, you need to find a common denominator. So I have x plus 1 over x, but the common denominator is going to be x plus 1. So I need to multiply the top by x plus 1. On the other one, I'm going to have x times x plus 1, so I'm going to have x times x in the numerator, but the bottom will be x times x plus 1 as well, and that equals 0. So now when I combine fractions, I have x plus 1 squared minus x squared all over x times x plus 1. I'm going to FOIL this. And then I'm going to cancel that term with that, because that's x squared and then minus x squared. So I basically have 2x plus 1 over x times x plus 1. So now to find the zero of a rational function, I just have to look at what the denominator or numerator is. And so I'll set 2x plus 1 equal to 0. X is equal to negative 1/2. Now, this may be very confusing for some of our pre-calc, our regular pre-calc students. So this is definitely a problem that if you don't understand what we're working on, we want to battle through, because when we get to topics like implicit differentiation, some of the decisions we made will become critical as far as being able to do that. But again, it's something that we can work through. I've done it tons of times with worked through it tons of times with lots of kids from regular pre-calc, and we've been quite successful with it. So if you feel like you don't really know what's going on this problem, there's time to learn this, but you gotta make a special note of that. So that's it for page 6, I believe, and I'm going to pause, and we'll get working on page 7 shortly.